Okay, so then from the name current amplifier, I am going to draw the circuit. Forget the circuit what is given here. You understand the concept how we are going to draw the circuit. So current amplifier, you have the current gain given by the current gain AI is given by I naught by IN. Okay, and measuring current in both the input and output side. So input side also I'll be having a current source, output side also I'll be having a current source. Is that logic clear to everyone? First, since current amplifier will predominantly amplify your current, I can you can define a parameter current gain given by AI is equal to output current by input current I naught by IN. So since I'm measuring current in both input and output side, I'll be having current source in both input and output side. And you know, whenever you have current source, you will be having a parallel resistance. Okay, so see here, I'm having a source current IS, I am having a parallel resistance RS. And usually, as usual, you will have your input impedance RI. And remember, the current flowing through RI is going to be II. Okay, the current flowing entering the amplifier is input current. Output side, you see, you have a current source parallel to R0 and this RL as usual. And this value of current source is given by cross multiply I0 equal to AI into II. So I0 AI into II, you have an output resistance and you have the load resistance RL. Is this clear to everyone? Drawing the circuit from the current gain equation. And usually this is represented as a Norton's equivalent. Whenever you have a current source parallel to resistance, you call this as a Norton's equivalent circuit. Whenever you have an voltage source series with resistance, you call it as a Thevenin's equivalent circuit. So both of the input and output side, I'm going to have Norton's equivalent circuit for current amplifier and Thevenin's equivalent circuit for voltage amplifier. So current gain is given by AI equal to IL by II. Output current by input current, I naught by IA. Sometimes since it is flowing through RL, you call it as IL by IA also. So ideal current amplifier is an amplifier which provides an output current proportional to input current independent of source and load. As we again repeat this point, any amplifier should provide gain independent of the source and load resistance. RS and RL should not determine the gain of your amplifier. The gain should be independent of RS and RL. Okay. And current amplifier, it will be opposite if you see. RI will be very much less than RS because whatever current coming out of this current source should enter this RI. Should enter the amplifier, right? So if it has to enter the amplifier, then RS should be very, very large. Then only current will not choose a high resistance path. Current will always take a low resistance path. At the output side, you see whatever current coming out of the amplifier should go to your load. So this resistance R0 should be very, very larger. Then only the current will take the least resistance path across your RL. Okay, so the conditions will be reversed here. You have to see the condition, seeing the circuit. See, my aim is maximum current flow through RI. So in this case, when you have two resistance in parallel, maximum current will flow through Ri only when this resistance is larger. Because current always prefers a least resistance path. In the output side also, you have two resistance R0 and RL in parallel. I want current through RL to be maximum. That happens only when R0 is larger. When R0 is larger, current will prefer the least resistance path. It will take the path through RL. So that is why the conditions Ri is very much less than Rs and R0 is very much greater than RL is given as the conditions in current amplifier.